Let's embark on a journey through time. We are going back to the very beginning, the birth of everything we know and cherish. Imagine a time approximately 13.8 billion years ago. This is where our story begins, with the Big Bang. It is the event that scientists believe marked the beginning of our universe. The Big Bang wasn't an explosion in the traditional sense. There was no pre-existing space or time for it to explode into. Instead, the Big Bang represents the rapid expansion of space-time itself from an extremely hot and dense state. Before the Big Bang, all of the universe's matter and energy were compressed into a single point known as a singularity. Then, something incredible happened. This singularity started to expand, creating space and time as it did so. The universe we know and love was born. The Big Bang is a theory. However, it is the prevailing cosmological model for the universe. This is because it is supported by a wealth of observational evidence. This evidence includes the redshift of distant galaxies, the cosmic microwave background radiation, and the abundance of light elements. The Big Bang theory offers the best explanation for the universe as we observe it today. Imagine, if you will, all the matter and energy in the universe squeezed into a space smaller than an atom. This incomprehensibly dense and hot point is what we call the singularity. It is a place where the laws of physics, as we understand them, break down. The singularity is a concept that pushes the boundaries of our understanding. It is difficult to comprehend the true nature of such an extreme environment. However, it is thought to have contained the seed of everything that is, was, and ever will be. The singularity did not exist in a pre-existing space. It was not surrounded by nothingness. It was the singularity itself that expanded to create space and time. Think of a balloon deflating. The air inside the balloon represents the singularity. The balloon itself represents space-time. As the balloon deflates, the air inside spreads out. Similarly, as the singularity expanded, it created space and time, leading to the universe we observe today. In the first fraction of a second after the Big Bang, the universe underwent a period of rapid expansion and cooling. This is known as inflation. During inflation, the universe expanded at an exponential rate, becoming billions and billions of times larger in a fraction of a second. As the universe expanded, it cooled. Think of how the air escaping from a balloon feels cool. This is because the expanding air is doing work and losing energy. In a similar way, the expansion of the universe caused it to cool. The early universe was incredibly hot and dense. As it cooled, energy began to convert into matter, following Einstein's famous equation E equals mc squared. This process led to the creation of the first fundamental particles. These particles were not atoms yet, but they're building blocks. These included quarks, leptons, and bosons. These particles interacted with each other, forming a primordial soup of matter and energy. As the universe continued to cool, the primordial soup of particles began to thin out. This cooling allowed for the formation of more complex structures. Quarks, the building blocks of protons and neutrons, began to combine. The strong nuclear force, one of the four fundamental forces of nature, bound these quarks together. This led to the formation of protons and neutrons. These protons and neutrons would eventually become the building blocks of atoms. However, the universe was still too hot for atoms to form. The newly formed protons and neutrons were constantly colliding with each other, breaking apart as soon as they formed. The universe was a chaotic and energetic place. It wasn't until about 380,000 years after the Big Bang that the universe cooled enough for atoms to form. This event is known as recombination. This marked a significant change in the history of the universe, as light was finally able to travel freely. Section 5. The Dawn of Stars and Galaxies. After recombination, the universe entered a period known as the Dark Ages. Now, this name is a bit misleading as the universe wasn't dark in the traditional sense. It was filled with a faint glow of light left over from the Big Bang, known as the cosmic microwave background. During this time, gravity began to play a crucial role. Slight variations in the density of matter in the early universe caused matter to clump together. These clumps grew larger over time, pulling in more and more matter. These clumps of matter eventually became so massive that their cores began to collapse under their own gravity. This collapse caused the core to heat up, eventually reaching temperatures high enough to ignite nuclear fusion. And so the first stars were born. These early stars were massive and short-lived. They burned brightly for a few million years before exploding as supernovae. These supernovae seeded the surrounding space with heavier elements, paving the way for the formation of more complex structures. Section 6. A chaotic dance of galaxies. Over time, gravity pulled together vast clouds of gas and dust. These clouds collapsed to form galaxies, the building blocks of the large-scale structure of the universe. The early universe was a chaotic place. Galaxies were constantly colliding and merging, shaping the universe we see today. These galactic collisions were not like car crashes where everything comes to a sudden stop. Instead, they were more like two clouds of gas merging, with stars swirling around each other in a complex dance. These collisions played a vital role in the evolution of galaxies. They triggered bursts of star formation and helped to drive the growth of supermassive black holes at the centers of galaxies. These collisions also helped to distribute the heavier elements created in stars throughout the universe. These elements, such as carbon, oxygen, and nitrogen, are essential for the formation of planets and life. Section 7. Birth of our solar system and the young Earth. About 4.6 billion years ago, in a relatively quiet corner of the Milky Way galaxy, our solar system began to form. A giant cloud of gas and dust, known as a solar nebula, started to collapse under its own gravity. As the cloud collapsed, it began to spin faster and faster, like a figure skater pulling in their arms. This spinning motion caused the cloud to flatten out into a disk, with the majority of the mass concentrated at the center. This central mass eventually became our sun. The remaining gas and dust in the disk began to clump together due to gravity. These clumps collided and stuck together, gradually growing larger and larger. Over millions of years, these clumps formed the planets, moons, asteroids, and comets that make up our solar system. The Earth, our home planet, formed in this chaotic environment. Early Earth was a very different place than it is today. It was a hot, molten world constantly bombarded by asteroids and comets. The atmosphere was toxic, and there were no oceans or continents as we know them today. Section 8. The cooling Earth and the formation of oceans. Over time, the Earth began to cool. The bombardment of asteroids and comets slowed down, allowing the planet's surface to solidify. Volcanoes erupted, releasing gases from the Earth's interior. These gases formed the early atmosphere, which was very different from the atmosphere we breathe today. It was mainly composed of nitrogen, carbon dioxide, and water vapor. As the Earth continued to cool, the water vapor in the atmosphere condensed. This condensation led to the formation of the first oceans, covering most of the Earth's surface. These oceans were initially very hot and acidic, but gradually became more hospitable to life as they cooled and interacted with the planet's crust. Section 9. Conclusion. The spark of life. The formation of the Earth and its oceans marked a pivotal moment in the history of the universe. The stage was set for the emergence of life. The exact details of how life arose from non-living matter remain one of science's greatest mysteries. However, we know that about 3.8 billion years ago, the first single-celled organisms appeared in Earth's oceans. These simple life forms were the ancestors of all life on Earth today, from the smallest bacteria to the largest whales. The Big Bang may seem like a distant event, irrelevant to our daily lives. However, it is the event that set in motion the chain of events leading to our very existence. Every atom in our bodies, every grain of sand on the beach, every star in the night sky was once part of that infinitesimally small point that we call the singularity. When we look up at the night sky, we are looking back in time, witnessing the echoes of the Big Bang. The universe is still expanding, still evolving, still full of mysteries waiting to be uncovered. The journey that began with the Big Bang is far from over. We are part of that journey, and our explorations and discoveries will continue to reveal the wonders of the universe for generations to come.